Hello and welcome to the final webinar in a series of 13 on berry crop nutrition and soil management. These webinars were developed for training ag educators and commercial berry growers. The webinars were recorded as part of a 2-year Northeast SARE professional development project led by Dr. Marvin Pritz, small fruit horticulturalist and berry crop nutrition specialist at Cornell University. The speakers for this week's webinar are Mr. Jeff Miller, Association Issue Leader from Cornell Cooperative Extension in Ida County, Laura McDermott, Extension Associate with the Capital District Vegetable and Small Fruit Program from Cornell University, and your host, myself, Cathy Heidenreich. I'm Extension Support Specialist with Cornell University in the Department of Horticulture. The agenda for this week's webinar, apart from the introduction of speakers, which we've already done, is the presentation. And the topics of the presentation will include an introduction to berry soil and nutrient management, discussion of the basic soil test, pH modification and testing, the Cornell Soil Health Test, and tissue analysis. If you'd like to listen to the other recorded webinars in the series, you may do so by going to the link below. Down below in the files box, you will see there are several files that you can download. The berry soil and nutrient management revision 2 is a PDF of this presentation. There's a grower pre and post test you can take to test your knowledge before and after the presentation. There's a chart that gives you the desired ranges for foliar analysis for strawberries, blueberries, and raspberries. And then the submission forms for the standard Cornell Soil Health Test form, the standard tissue test form P, or the Cornell Soil Health Test down below. Also listed over in the web links box is again the link for the recorded berry soil and nutrient management webinars and the Cornell Fruit Resources berry pages. And without further ado, we will move to the presentation screen, and Jeff, we're ready for you now.
Thanks, Kathy. I'm going to take a couple minutes in the beginning part of this presentation to talk to you a little bit about soil testing, soil sampling, and we'll start off talking to you a little bit about soil and tissue testing. It's pretty hard to manage a crop unless you have some pieces of information to help you manage that crop. And that's really where soil sampling, soil testing, and tissue testing come in. There's definitely two main time frames that we talk about when we talk about sampling, and that's pre-plant. So if you're planting an expensive crop like raspberries or blueberries, and you want to prepare the soil beforehand so that you have the least amount of obstacles and the most optimum conditions for those expensive crops, is a great opportunity to take soil tests and get analyses back and have time to actually make some adjustments. And for these crops, one of the major things that you have to think about is things like soil drainage as a possibility, getting irrigation to the site as a second possibility, but really what we're talking about today is the fertility management. And one of the things that you can change is pH. If you plan on doing a blueberry planting, you know that you want to get the pH down into the 4s, at least mid-4s. And if you do not do a soil pH test in advance of the planting, then you're probably not going to have enough time to modify that pH and have it down in the range that's optimal for that crop. And the same would be true in acid soils and bringing them up to 6 or 6.5, depending on whether you're going to go with raspberries or strawberries. So it's a real opportune time to take those samples. Another time to think about soil sampling is after the planting's already in, and this is the case where you're talking about maintaining a viable stand at optimal performance and taking samples of soil, running them through a lab and getting an analysis back, and then making sure that there's no major shortages of any important nutrients, And if there are, making sure that you're applying those nutrients in adequate quantities to optimize both crop yield and quality. A last thing that growers should consider is protecting the environment. So if you look at it and you say, well, to the average grower, how much do you apply, and do you do soil testing? There's often enough times where you hear the answer, I don't really do an awful lot of soil sampling, but I make sure that I never short the crop. So that means that there's a possibility that there's over-fertilization going on, and that can be very costly, and depending on the nutrient, that could have some environmental ramifications as well. Now, just talking to you about the basic types of testing, the standard soil test, which is a chemical analysis, the Cornell soil health test, and tissue analysis. If you look at a standard soil test, it's something that's conducted at many labs across the states, and the attempt is to measure the availability of essential nutrients for plants. So each lab has their own setup, their own procedures, their own material is used to leach out nutrients, and measurements taken on the quantity of those nutrients that are then reported back to the growers. In New York State, Cornell has done an awful lot of field research and done some tests to look at what is in the soil and application rates and the response to application rates given different soil levels of those nutrients. So that's the basic chemical analysis that people would get reports back, interpret them, and adjust their fertility and pH accordingly. The Cornell Soil Health Test is a unique test looking at some of the other attributes of the soil, and that's the biological aspects and the physical aspects of the soil and how they impact plant growth and development. And Laura's going to be talking to you about that a little bit later in this presentation. And then finally, tissue analysis. This is a great way to measure what actually the plant is seeing in the way of nutrients. If you do soil tests, you can see, well, this is what we have in the soil, but the tissue analysis tells you what the plant is taking up from the soil. And Kathy's going to talk to you a little bit more about that later. There's two basic times that you would look at testing. One is the routine measurements. If you have an established planting, you take samples every 3 years, you look at the results, you make some minor modifications, adding phosphorus when it's needed, or modifying the pH if it's needed, either down or up depending upon the crop. And or if you have a situation where you have no history of a site at all, and you plan on putting a planting of perennial berry like blueberries into an area, it's a great opportunity to do that soil test at that time. That's more of the routine types of tests that are conducted. There's definitely a chance to use soil testing and foliar analysis to do diagnostic work when plants are not doing as well as you think they should. And it's just one piece of the of information that you can use to help come up with answers for local growers to actually identify what the problem is on the site. And usually this is done with doing some paired sampling. So taking a series of samples in an area that is just not performing up to par, and then comparing them with at least the results of those chemical analyses with an area of the field where you have reasonable performance. In these situations, adding soluble salts as an analysis is probably an important thing to do. And using plant tissue analysis just gives you that additional piece of information that you can use in answering a battery of questions and narrowing down the field to the problem. Now, it's important to look at how you'd want to obtain a sample. In the case of the problem identification, you can see that by the green arrow, there's an area of sweet corn in this case that's not performing very well, and yet a majority of the rest of the planting is doing very well. This is an opportunity to take some samples to identify what the problem might be. So in sampling these areas, you'd want to take a series of samples from the area that's not performing well, and you should take a minimum of 8 subsamples that are then mixed together as a single sample from both the problem area as well as the area that's more representative of good performance. So that's one sampling strategy. Another important thing to consider when you're sampling is actually to sample by management unit. So you can picture your farm and you can picture block planting of that farm over time. You would want to first look at the soil types that are underneath these plantings, and if there are major changes in soil type, to actually sample within those soil types, because there can be very big differences in their ability to hold on to nutrients, the amount of lime or sulfur that's needed to change the pH depending on the texture differences between those soil types. So that's the starting point. But beyond that, you may have a planting of strawberries that's newly planted, and that should be sampled separately than plantings that are 2 and 3 years old. And even within those plantings, maybe you have different varieties planted. You should be considering them as management units and doing sampling separately for those management units. And then using it as a diagnostic tool is yet the other method. So talking about a sampling of soils for chemical analysis, there are different labs. They use various extractants to estimate how much plant available nutrients are in that sample. And yes, the values that you can get from the same sample can be very different from different labs. And the important thing to take home out of that is not to take values from one lab's results and try to make recommendations using another lab's information. So in New York State, the recommendation is to go with Cornell soil sample analysis, and that is being conducted by a private firm, Agro-One, because then you get the power of the university and all the trials that are conducted and the information gleaned from those trials and the recommendations that come from those trials. So Agro-One is the place to go in New York State, mainly because you get the benefit of the Cornell recommendations, which are based on research results. There are a certain set of sampling tools that can be used in obtaining soil samples. In the upper right, you can see a series of those tools. You have an auger, soil probe head, and you can see that they're made from stainless steel. One of the important things to avoid is contamination of the sample. So if you use steel shovels, spades to obtain the sample and they haven't been cared for and there's some rust on them, that can actually contaminate the sample. Another thing to think about when you're taking a sample is you're trying to be as representative of the situation as possible. It is just a sample from the field. So getting to the same depth consistently, making sure you have the same volume of soil that's obtained at each site, and then mixing each one of the subsamples to come up with a composite for an entire area. All those things give you good information. If you got too much sample from one site and not enough from another, now you're actually weighing the sample results. And if you don't have sufficient numbers of samples, you can definitely have some errors in the information that you're going to get from the sample results. Another thing to consider is to make sure that you're using a plastic bucket. Some buckets are made from zinc, and zinc can contaminate the sample as well. And the third thing is make sure that you're using the appropriate forms and appropriate procedures in putting together the sample to send it off to the lab. Now, looking a little more closely at the soil probe, this is a favorite among a lot of people, and the reason why it's a favorite is you have this tube that's attached to a T. You can press this into a soil, get a nice core sample to the depth that you want to go to, clear this tube, and then move on to your next site. So under good conditions, so that's not too wet, not too dry, and definitely not rocky or gravelly, you can do this very quickly. And so a lot of people use this particular device to obtain samples. I will say one of the things that I do is whatever depth I'm going to for a specific crop, I'll measure it right on the probe, and then I'll put a piece of electrical tape around the tube at that height so that I consistently go to that same level. Looking at the auger is a great tool under rocky and wet conditions. If it's too wet and you use the soil probe, anybody that's done this, you press it in the ground, you pull it back up, and only half the tube is actually filled because you actually compressed the soil when it was wet and you didn't get a full tube's worth of sample. So under wetter conditions, the soil actually adheres to the auger, and you just run your hand down the auger to clear that, and you've got a reasonable sample. The same thing can be done with the auger, where you measure, let's say, 8 inches from the tip to the top, and make sure and put your electrical tape there, and then you know that you're going to that depth consistently. Another benefit of the auger is that you can actually set them up so that you can put them on a power drill if you're doing a lot of samples. And some thought has gone into this where people have cut a hole inside a container like a bucket, a plastic bucket, and actually run the auger right through the bucket, through the hole, into the soil, and bring it back up, and they clear it right there, and the sample's trapped in the bucket. So a pretty efficient way of sampling. As was mentioned before, you definitely want to take at least a minimum number of samples to get a good representation of any given area. Another thing that you should consider is never do sampling in, let's say, straight lines. Why is that? Because a lot of times we are running in straight lines up and down fields with our equipment, with fertilizer, and planting, maybe doing drainage work. And if you sample over that same area consistently across the field, you actually are not representing all of the rest of the area, and you may actually be tainting the results. So usually the recommendation is to zig and zag across an area to obtain a sample so that you're getting a good representation of the entire area. To start sampling, you always remove the organic debris that's at the surface, because that will change the results. You make sure that you know the depth at which you should be sampling for the crop that you're actually sampling for, and it would definitely be different depths for tree fruits versus small fruits versus things like field crops and turf grass. So make sure that you know the depth for the crop that you're actually sampling for. You should definitely take 8 to 10 subsamples at a minimum in an area anything less than 2 acres, and anything greater than 2 acres you should have 10 to 20 subsamples as a minimum. In larger acreages you want at least a minimum of 3 subsamples per acre. For sampling for berries, both pre-plant and established plantings, you want to go down to 8-inch depth. And then in established plantings, you want to pair up the soil sample results with tissue analysis. And Cathy will talk to you a little bit more about that later. Additional guidelines, remember to remove that organic mat to go to the depth that's recommended. Taking each subsample, putting it into the plastic bucket. At the end of sampling a particular area, mix well, because now that is going to represent that area, and then you subsample from it to get your sample to send off to the lab. If the sample is too wet, then put it on something like a plastic plate, put a fan on it to air dry it. Avoid using any kind of heat source because that can definitely skew the results, especially nitrogen. And then make sure that you put it in the appropriate container for the lab that you're sending it to. And make sure that your forms are completely filled out because they use that information in making the recommendations. In New York State, they have mapped the soils out. They've actually done it in the whole U.S., but they use the soil names in New York State to provide information about yield capacity of the site and some of the physical attributes of the soil and its ability to hold on to nutrients. So it's important to put the soil series name on the form indicating for the area that you're sampling for your crop, because that is a valuable piece of information that adds into the recommendation. In fact, you won't get a recommendation without having that information on the form. So you can go online and use websoilsurvey.nrcs.usda.gov and get the soil survey for your farm, and then specifically get down to the field level and indicate what soil series name is most predominant in the field or the area that you're intending to sample. There's actually an iPhone app, and you can get this from this presentation and actually use that to find the soil name for your particular location. And or if you don't want to go either of those routes, you can go to a cooperative extension office. Often they have copies of the same materials and can help you to identify the soil name for your field. Interpreting the results can be challenging. If you go to an out-of-state lab, they might send you results back just indicating the pounds of particular nutrients that are tested in the sample and no recommendations. And that's why it's important to really use the lab that's in your state that is associated with a local land-grant institution and can provide recommendations. Just a simple thing like checking your soil pH, you definitely have to have the information ahead of time that if you're growing strawberries or raspberries, that the pH that is recommended that's optimal for those crops is between 6.2 and 6.5 versus blueberries much lower at 4.2 to 4.5. You look at the results and say, okay, are my macronutrients, do they fall into the medium range or above? And if not, then I need to make some adjustments in that. Here's the recommendation on the soil sample results. What's your soil organic matter content? For most berry crops, it's recommended to have 3% or higher. And again, this is one of those things, if you test the site beforehand, you have a chance to actually build up organic matter levels if you need to. The calcium levels are very important for blueberry production. And the recommendation is when you're looking at a Cornell soil test results through Agro-One that calcium be below 2,000 pounds per acre. And aluminum can be toxic at higher levels. So if you see a reading of 300 pounds of aluminum in your sample per acre, then this is a situation that you're going to have to correct very quickly. And that can occur more and will occur more under acid soils. And definitely there's a recommendation not to use any kind of aluminum-based fertilizers. So just a quick word about soil pH. If you look at this graph, it's one that probably you've seen before that indicates the availability of some major necessary nutrients for your plant growth and development. And it just shows the wider the band, the more available those nutrients are. So you can see that in the pH range of, let's say, 6 to 7, you find that most nutrients have a high availability. As you go towards strongly acid, the availability of many nutrients falls off, and that can affect the performance of your plants. Or if the pH gets driven way up, you can have that same situation at least for a series of these nutrients that are necessary for crop growth and development. So it's very important for you to understand that relationship and how important it is to have the pH in the soil at an optimal level for the crop that you're growing. When you're modifying soil pH, one of the things that you should be aware of is that it isn't instantaneous. You can't just apply lime to increase the pH or sulfur to decrease the pH one day and have the pH changed by the next day. In fact, it's a long-term process and takes from 6 months to 9 months to occur. So this is better that you pre-plan, do the testing beforehand, make adjustments in pH through these applications, and do that 9 months or more in advance of actually planting the intended crop. And if you want more information on this, you can go to the production guide for berry crops put out by NRACE. And this is what you might expect. This is what you would get from Dairy One as far as a results form. And you can see that they have a nice graphic in the upper right, which shows you very low, low, medium, high, and very high levels of some of your major macronutrients. And you can see, for instance, that phosphorus is in the low medium level and probably would need to be built up with additional applications. Potassium is already high, so pretty reasonable. Calcium, we talked about that 2,000 pounds of calcium per acre being an indicator of at least above that being a problem for blueberry production. pH 6.1, and looking at strawberries as the intended crop, we're close to the range that's recommended. And then organic matter, we talked about the fact that you wanted 3% or more, and in this case you have 4.6%. Aluminum, we said that you had to have 300 pounds per acre or more to have problems with toxicity from aluminum, and it looks like we're okay in this case. Nitrogen recommendations from this sample, 100 pounds of nitrogen total to be split, 80 pounds in July, 20 pounds in the following September, and then 25 pounds of phosphorus fertilizer at planting. And when it comes to bringing those nutrient levels up to recommended levels, it's really the same. The soil test results will tell you, okay, you need so many pounds of P2O5 or K2O, potash or phosphorus, nitrogen. And really, it's when you talk about organic versus conventional, it's just the source that you're changing. So the percentage of nutrients found in organic fertilizers is usually lower than those found in conventional fertilizers. But if you're told to put on 30 pounds of nitrogen, then you just have to put on more material of the organic type of fertilizer to achieve the same 30 pounds of nitrogen contribution to that crop. And you have two really, really, really good guides, the organic strawberry and organic blueberry production guides, to help you find sources of fertilizers and bring those soils up to spec for optimal production of those crops. And with that, I think I'm going to be turning this over to Laura for further discussion about the Cornell Soil Health Test.
All right, thank you, Jeff. So we talked a little bit about one aspect of the Cornell Soil Health Test, which was the chemical evaluation of the soil. But a higher level of testing involves evaluation of biological and physical properties of the soil, in addition to the chemical ones that Jeff explained. and those are measured in the standard soil nutrient test. All three of the components, biological, physical, and chemical, interact to provide conditions that could lead to optimal plant performance. Chemical properties are the most understood, and they're the easiest to modify of those three, but we can also influence soil physical and biological properties to enhance plant performance. And that's why the soil health test is so valuable, because it gives us some idea of what some of those constraints might be. So this is a slide that explains a little bit. The Cornell Soil Health Test was developed by the Cornell Nutrient Analysis Lab, and there's a whole team of folks that work on soil health at Cornell, not just agronomists, but horticulturists, soil scientists, etc. And they came up with the Cornell Soil Health Assessment Training Manual, which is right here. You can order this online. It's downloadable. And it's very helpful for folks that are just beginning to understand what soil health could mean. This is the address and the website that you can get more information about this process. And there's basic packages and standard packages. And the basic is really for grain and forage crops and other non-agricultural applications, especially used for landscaping and site remediation. But for us, with specialty crops, the standard package is what we are recommending that you get. And this is used a lot in vegetable production. Organic producers are very interested in this information. Some problem diagnosis, again, in landscaping and urban applications. And for berry crop growers and tree fruit growers, especially perennial plant growers, the best time for us to take advantage of what the soil health test can offer is for first-time soil health assessment. So soil health is the capacity of the soil to function chemically, biologically, and physically. And that's what we're going to explore a little bit. And that's what the soil health test will make sure that folks understand. So characteristics of healthy soils include good tilth, sufficient but not excessive amounts of nutrients, a sufficient rooting depth. Healthy soil has good water storage and also excellent drainage. Those are very important in berry crop production. It is free of chemicals that might harm plants and has relatively low populations of plant disease and parasitic organisms, but high populations of beneficial organisms. Healthy soil has lower weed pressure, and it has some resistance to being degraded. And all of these help it become more resilient. So it's actually quick, it has a capacity to recover quickly from adverse events, and those are characteristics of healthy soil. Some characteristics or signs of poor soil health include when you plow up cloddy soil and you have poor seed beds, those are signs that you might have poor soil. You might have hard soil at planting. It tends to kind of get that surface soil hardness on it, which is a real problem. There could be rapid onset of stress or stunted growth during dry or wet periods. That's a sign of unhealthy and poor soil. And it can also have poor growth. The vigor on the plants is just not great at all. You might see in poor soil declining yields. That actually is one of the biggest tip-offs to growers that there's something happening. Their yields just keep going down regardless of how much fertilizer or organic matter they might be adding. And that this also can exacerbate high disease pressure when you get poor vigor. A lot of times diseases take advantage of that. And then that you might see signs of runoff and erosion. So those are pretty obvious poor soil signs. So some of the interactions, and this is what the soil health test will help delineate or help make obvious is some of the things that they will indicate to you will have interaction. And so hard soil reduces rooting, but why does that happen? It could be compacted dense soil layers restrict rooting volume, and then the plants are not able to exploit water and nutrients the way they should be. Compacted soil can also suppress beneficial biological processes. And so you see in blue is the physical attribute, and then in green, nutrients and root diseases and denitrification all are chemical aspects, and the yellow is the biological. So poor drainage reduces rooting and aerobic biological processes. And then the compaction, which a hard soil, often you'll have compaction, that will increase root diseases and denitrification losses. So that's an example of all three of the characteristics, the soil characteristics, having an interaction around hard soil. So some of the things that the Cornell Soil Health Test will do is that there's a battery of tests that are employed, and some of these are done in the soil health. The photos of the suite of analyses, the soil physical tests are in the blue across the top. These are all laboratory tests except the field penetration test, and we'll talk about using that soil penetrometer a little bit later. And then the biological tests are in green across the bottom. The soil health lab uses a modified Morgan extraction solution to determine soil nutrient levels. And then the soil texture determination is also used to categorize test results. Cornell Soil Health Test guidelines, and this is just some things that you'll need in the field. Basically, I find that it's easier for me to take this test if I have an assistant, somebody to help carry some of the gear. But if you're alone, you'll definitely need two 5-gallon buckets, and one of them would be for soil. We gather much more soil in this particular test than you do for a chemical soil analysis. You want a large 1-gallon Ziploc bag to put all of the soil sample in at the end of the gathering it. You'll want a 600 ml or plastic beaker, a 3-cup capacity. You'll want a permanent marker and pen. I use a trowel or a spade, and I actually use a larger kind of a tree spade type thing, and that helps a lot to gather that soil. You want a soil penetrometer, a grower and field information sheet, and a clipboard to hold that information on. And so this right here is an example of that soil health field information sheet that you'll be filling out. So these are rather important guidelines, and the sampling will be done roughly in the same manner for the standard chemical soil, the nutrient soil test, with some of these exceptions. You want to sample the soil in the spring when the soil is at field capacity. So that means that it needs to have enough soil moisture to be tillable, but it can't be saturated. And that was a difficult thing this spring. We had such a dry April, it was difficult to get any kind of field capacity in most soils. So, and then it started raining like crazy, so it makes it hard. The soil health test should ideally be done before tillage occurs. And sometimes that's not an issue in a perennial crop because we don't do a lot of tillage, but you do want to be aware of that. Also, you want to have these soil health test samples gathered before the end of June because the lab stops analyzing the samples sometime in July. So try to make the end of June being your kind of cutoff date if possible. You want to use a trowel or a spade to sample soil as a larger volume of soil is required for this test. Again, I use kind of a tree spade. So that allows me to gather kind of a nice sample on that. You're going to be making 5 stops across the field, and you're going to be, again, zigzagging kind of in that W type of random pattern. You want to collect 2 subsamples samples at each stop, and you're going to mix those subsamples thoroughly and then put that into the bucket. At each of those stops, you want to make 2 penetrometer readings, one from 0 to 6 inches and then 6 to 18-inch depths at each subsample location. And actually, if we go back to that form, right down here is this area where you're going to have push 1 and push 2 for the surface and then the subsoil samples. And you're going to be doing that for each of those 2 locations. So you end up with quite a few readings there. Then you're going to record that on the form. After you've done this, you'll have at least 1.5 or 6 full cups. And then that's what the 3-cup measurement is. You want to take that, make sure that you have enough, mix that soil into a Ziploc bag, label it with the field name, the ID, and the date on that Ziploc bag. Now, next, you want to make sure to keep that sample out of direct sunlight, putting it immediately into a cooler. And then if you cannot get this shipped right away, you want to put it in a cold room or a refrigerator the entire time that you're shipping. So I will bring a cold pack in my cooler, put that soil sample in there, and not let it warm up. The reason being that you don't want any degradation of organic matter to happen. So just be aware of that. It also makes shipping somewhat difficult because this is a rather large sample. It's quite heavy, and it still needs to be cooled during shipping. So you're going to have to be aware that you'll need some kind of a styrofoam container, probably put a cold pack in if possible, so that the sample can remain cold during shipping. And let your grower clients also know that you're going to need to have some, they're going to need to pay for the shipping. It is something to consider, especially if you're doing multiple samplings. So interpreting soil health test results, make sure to understand, and this is something that it took me a while to understand, that the report is a management guide. There is no real hard and fast prescription. But what it does give you are those kind of readable data so that you can try to figure out your management around the data. Different management approaches can be used to mitigate the same problem. So that's something that you and the grower would discuss quite a lot while you try to understand what's the easiest and most efficient and also economical approach for the grower. In addressing some of the soil constraints, management practices can affect multiple indicators. So some of your things that you might do, like using cover crops, might actually mitigate many different things. And soil health changes slowly over time. One thing, though, to be aware of is that we use this in a vegetable situation. We actually were looking at things back to back, and we actually did see some improvement even in 1 year. So it is a long-term process. Oftentimes they won't see changes, but it's wonderful that now we have a tool that we can kind of track these changes when they happen. So here's an example of 2 soil health tests. This is what they look like. We get this kind of, we can learn the effects of long-term moldboard plowing. That's what we're looking at here. 14 years of fall plowing. This is a corn for grain study on a clay loam soil. The soil physical properties have been affected, as have the biological properties. A steady diet of corn stover has maintained soil organic matter, but it's impaired active carbon levels in the no-till. This field started out as an alfalfa hay, and we see that no-tilling maintained a healthy soil, which gives it the high score, while the continuous tillage had measurable effects and results in the low score. And let me just see if I can get my So you can see that this test on the left is the we get aggregate stability, which is in a danger thing. That's the red, indicates some danger. Available water capacity is also in that red danger zone. Surface hardness, it has a very excellent rating, probably because of all the tillage that's happening. But the subsurface hardness, still you have a subsurface pan, deep compaction resulting. Organic matter, the yellow indicates kind of a warning sign. It's at 3.9, which is the percentage. It still seems like it should be good, but for some reason it does not rate that high. Active carbon is very poor. There's soil biological activity is low, and potentially mineralizable nitrogen is also in that area. But the rural health rating is still quite good. So sometimes some of these things you wonder, there doesn't seem to be a clear picture across the board in one biological area. Soil pH is a little bit, from a nutrient or a chemical aspect, 6.1 isn't bad, but they put it in the yellow range. Extractable phosphorus is a little bit high, probably, so that puts that into a yellow area or caution. Extractable potassium is fine, and all of your minor elements are fine, but that rating gives it a low reading. Whereas on the right, the same kind of situation, but they've done no-till, you can see that all of the aggregate stability, the subsurface hardness, the organic matter, and the potentially mineralizable nitrogen, things that were in the red areas now are green, giving it a much higher rating, so the soil health then is deemed better. And we aren't as lucky. A lot of times we have a no-till situation just because berry crops are primarily no-till. So, approach for a successful soil management strategy, you want to assess your soil's health to identify constraints, and that's what we're recommending doing with the Cornell Soil Health Test. You want to be able to make changes in management strategies that work for your farm and that address the specific constraints identified in the soil health test. You want to be able to experiment on your farm to see what works in your situation. Starting small is helpful. And you should be able to adapt the many resources of information that you glean from the soil health test to your farm and build healthy soils to increase resiliency to extremes. And that's one of the overall goals. And now Cathy's going to talk about the Cornell tissue analysis, just tissue analysis in general.
Thanks, Laura. We want to take a look now at the above ground aspect of small fruit production, and we're going to look at tissue analysis or leaf analysis. And this kind of testing directly measures the amount of nutrients in the leaves. And in some instances, as incredible as it may seem, there may be sufficient nutrients in soil, and yet leaves can show a deficiency. And we'll talk about the reasons why that may happen. So these sufficiency ranges have been determined or estimated for small fruits, sometimes from other crops, sometimes directly. And so we'll be looking at those shortly. And these ranges, when you fall into the lower or deficient levels, alert you to nutrient issues that are coming. And often those can be caught before they become critical and affect yield and plant performance. These tests are also used to fine-tune annual nitrogen application rates. Typically, there's a suggested application based on the crop age, but you may need to adjust in your particular situation, either higher or lower, depending on the test results. And then these can also be used diagnostically, as Jeff discussed earlier, to rule out nutritional causes for poor plant performance. Oops, sorry, wrong way. So these tests can also be done at the Agro-One lab, and The information for the lab is here. These tests previously were done at Cornell at the nutrient analysis lab, and they've been shifted to Agro-One so that the nutrient analysis lab can continue to do the research needed to fine-tune the recommendations. And in this instance, you're looking for the tree fruit and small fruit form, Form P, and the report that you will get will give you the Cornell nutrient guidelines and the interpretation thereof, and the samples run roughly $24 each. So when would you need to collect leaves for the analysis? Typically, strawberry leaves are collected after renovation, and we're looking for the first regrowth, the youngest full-size leaves, and those are usually collected toward the middle to the end of July. For blueberries, these leaves are collected just before or during harvest, and you're sampling from fully expanded mature leaves from the middle of this year's shoot growth, and those that are exposed to full sun. Typically, these are collected in late July and early August. For raspberries and blackberries, you're collecting leaves from the primocanes, and you're looking for the youngest fully expanded leaves. Typically, they're collected in early August. One of the things that you want to remember, though, is that it's best to avoid collecting leaves when the plant resources are all being directed fully to fruit, because in a lot of instances those levels can fluctuate, and there may be sufficient nutrients in the soil, for example, but the leaves may show a deficiency. This is particularly true of potassium. So you want to be sure to try to collect when their plants aren't under a heavy fruit load. That's not always possible, but try to avoid that whenever you can. So how do we collect the leaves? Again, we want healthy leaves that are well exposed to light. They should be representative for the average condition of the planting. Try not to select leaves that are damaged by disease, insects, weather, for example, hail damaged or mechanical injury. Don't mix leaves from different cultivars. Remember, Jeff talked about management areas. You want to try to keep your management areas uniform. Plantings of different ages, leaves from those should not be mixed. Those should be separately sampled. And you want a minimum of 2 ounces of fresh weight leaves, typically 30 leaves for each sample. If possible, try to collect each leaf from a different plant within the sample area, and then try to process your leaves for analysis as soon as possible. Okay, when you prepare your leaves for analysis, one of the things you want to do is use distilled water for washing and rinsing the samples. Washing leaves removes dirt and residues that can affect the test results, so it's important to do so before they're dried for shipment. So gently and lightly scrub the leaves together in distilled water. Change the water if it becomes dirty or after 8 to 10 samples, whichever occurs first. Shake the leaves gently to remove excess water, and then rinse the sample in clean distilled water. Again, shake off the liquid and rinse with another clean water sample. You can lay these out on paper towels and let them dry slightly before you put them in a paper bag, and then you want to leave the top of that bag open and dry the leaves at room temperature until they're brittle. It's important not to let the leaves stand in water. You want to try to wash and rinse them in a minute or less if possible. Don't put them in plastic bags to ship them, or ship fresh leaves without drying, because they often can deteriorate really rapidly under those conditions, and it'll result in very poor test results. So here's the chart that I was telling you about, where we have the standard foliar nutrient ranges. And I want you to notice that when you look, for example, at strawberries, you have a range where the nutrients are sufficient, and then a range where they are deficient below a particular point. And you'll notice across the top, the nitrogen is expressed in percentages. That's true all the way down to boron, and then the ranges are expressed in parts per million, or ppm. And so when we look at strawberries, you'll see that the ranges if you compare those to raspberries, you'll see that for the most part, the ranges are pretty much the same for these two crops. You'll see there's not a lot of difference between, for example, zinc at 20 to 50 ppm, and the same for raspberries in the sufficient range, 20 to 50 ppm. But when we compare, say, for example, strawberries or raspberries with blueberries, you will see that blueberries have significantly lower levels. The critical values for blueberries are quite a bit lower. They have much lower nutrient requirements than strawberries and raspberries. One exception to this, however, is manganese. Higher manganese levels with blueberries is not a problem as it might be with other crops, because manganese becomes less available as the pH drops. So you can see here blueberries are able to tolerate manganese even at the 350 ppm range, whereas strawberries and raspberries prefer a range of 200 or less. Okay, it's important to note that not all labs will compensate for the differences between, say, for example, strawberries and raspberries and blueberries, in terms of the blueberries having lower nutrient requirements, and they will often use the same recommendations that they are using for strawberries and raspberries with blueberries, because these recommendations are common across a wide range of crops. And so they may be recommending addition of nutrients in blueberries where really they aren't necessary, and so that's one of the things you really need to watch for. Okay, here's a typical plant tissue analysis report from Farmer in the Dell at Hi-Ho Dario Road. These are blueberries. They're 1 to 3 years old. They're non-bearing, and the variety is Liberty. And you can see here there's a nice graphic that gives you the macro and micronutrients. The bar graph shows when they're in range or when they're low. Typically you get the most benefit when you address nutrient issues that are falling in the low to deficient range. That's when you really need to make corrective action. When they're in range or in the high range, that's when typically you won't get a lot of change in plant performance if you make those corrections. And so when we look at this report, we can see that both copper and iron are deficient. Zinc is also low. However, if we look at the soil levels over here, the levels for those nutrients are adequate. So what would the problem be here? If we go back and look at the soil test results, which is why you want to really have a paired sample, you'll notice that the pH here is 5.2, which is higher than you really would like for a blueberry planting. For blueberries, you really would prefer 4.2 to 4.5. When the pH reaches that level, the available nutrients in the soil will become available, and those deficiencies should correct themselves without even having to make an application. So when you're interpreting your results, be sure that the soil pH is within the correct range. Assess the status of the planting to determine if something other than nutrients could be limiting growth. For example, disease, insect pressure, drought, other environmental conditions. Be sure to check the status of boron, because that has an effect on other nutrients. Look for specific nutrients that may be deficient. Check for interactions or imbalances that exacerbate low nutrient levels, and then come up with your recommendations. When boron levels are low, that affects root growth and development, limiting the uptake of other nutrients such as calcium and potassium. Soil levels of these nutrients may be adequate, while leaf levels appear deficient. When you correct the boron levels, it will often correct the issues with the other nutrients without the need for addition of supplemental calcium or potassium. Another thing to note, as we discussed earlier, is that fruiting takes a lot of potassium. Soil levels of this nutrient may be adequate while leaf levels appear low. This is especially true as leaf sampling often occurs not long after fruiting. Allowing time for uptake and adequate irrigation will replenish leaf levels of potassium without the need of supplementing. Sometimes high levels of soil nutrients may also cause problems. For example, if phosphorus is too high, it may restrict uptake of micronutrients such as zinc, copper, or iron, or magnesium by tying them up in the soil. This frequently occurs in the case of strawberries. Another interaction involves high calcium levels in blueberry soils. This nutrient often ties up iron in the soil, causing a foliar deficiency. So when you're interpreting tissue analysis test results, there are some things to remember. First of all, the test results are not meaningful for fertility guidelines unless the soil pH is within the correct range. And remember that soil test results do not always correlate with foliar test results for a variety of reasons. So you may have adequate nutrition in the soil while there appears not to be adequate nutrition in the leaves. Or the reverse may also be true. You may appear to have adequate nutrition in leaves but not in soil. Tissue analysis tests are useful for diagnosis, but not for detailed guidance unless you consider all of the factors involved, including growth and yield. And applying nutrients may result in a decrease in foliar concentration under certain circumstances. Correcting deficiencies or imbalances in established plantings is more difficult than amending soils prior to planting. So really that pre-plant soil test and soil amendment prior to planting is critical and often provides enough nutrients, especially P and K and the micros, for the life of the planting. Nitrogen is something that we need to add annually, and I mentioned that it's often determined by the crop, the plant age, the irrigation and mulching status, and the leaf analysis results. So often growers will say, okay, my strawberry crop is 2 years old, and so I'm applying 25 pounds per acre of actual nitrogen. And if you actually used your leaf analysis results in comparison to the crop age, you might find that you had sufficient nitrogen and you might be able to apply less, or you might find that your nitrogen is actually lacking in leaves and you might need to apply more. And for more information on this topic, you should check the Cornell Pest Management Guidelines for berry crops to find the annual rates of nitrogen for your crop, or the NRACE production guides for more in-depth information on adjusting these to get the proper results. So again, in many cases, no additional P, K, Mg, or Ca will be required if the soil test recommendations were followed at planting. You may need to supplement K and potassium and boron, especially on sandier soils because those have a tendency to leach more quickly. And small amounts of sulfur may be required to maintain a low pH in some soils where blueberries are grown, especially if calcium levels are approaching 2,000. Leaf analyses provides guidance on supplemental fertilizers after the planting is established, and don't rely on a soil test for post-plant recommendations that do not involve soil pH. Remember, the pH has to be at the correct range. So in review, don't rely on visual symptoms of what you've always done in the past in terms of berry soil nutrient management. If you want to maximize your yield and plant health before you plant, consider doing the Cornell Soil Health Test, which includes the standard chemical soil test and more, the physical and biological properties that Laura discussed. And then after plants are established, use annual tissue analysis and soil testing every 2 to 3 years to fine-tune your nutrient plan. That's the end of our presentation today, and we'd like to acknowledge Dr. Marvin Pritz, who's the project leader of our project. He's the professor and chair of the Department of Horticulture at Cornell University. You've already met Laura, Jeff, and myself. We'd also like to thank Mario Miranda-Sazzo, one of our team members, who's with the Tree Fruit and Berry Fruit Extensions. He's Tree Fruit and Berry Extension Specialist with Cornell Extension Lake Ontario Fruit Team. Mr. Dan Welch, who's Extension Resource Educator with Cayuga County Cooperative Extension. Dr. Harold Verness, who's Professor at Cornell University in the Department of Crop and Soil Sciences, who works very extensively with the Cornell Soil Health Program. And Mr. Robert Schindelbeck, who's Extension Associate also in the same department and is the coordinator of the Cornell Soil Health Testing. And we have special thanks to Ms. Janet Fallon with Agro-One. She's the Certified Crop Advisor and was very helpful in providing information for this presentation. Thank you.